Okay, here's a question. We need to decompose x cubed plus 3x squared plus 6x plus 7 over x squared plus 3x plus 2 into partial fractions. So you look at this, and the first thing to notice is that, well, yes, this will factorize, but the real first thing to notice is that the degree of the numerator, which is 3, the highest power in the numerator, is higher than the degree in the numerator of 2. So when that happens, you say you've got an improper rational function. So if you get something like that and you need to split it up into partial fractions, your step 1 needs to be long division. So we need to use polynomial long division. We're going to divide the numerator by the denominator, and then we're going to see where we can go from there in terms of splitting the thing up into partial fractions. Okay, so we need to divide x cubed plus 3x squared plus 6x plus 7 by x squared plus 3x plus 2. It's not a nice linear thing that we're dividing by, so synthetic division is not an option. We could need to do full-blown polynomial long division longhand. So x cubed plus 3x squared plus 6x plus 7. So we look at the leading term in this into the leading term in that. To get x cubed, so to get x squared into x cubed, we need to multiply it by x. And then we multiply all of this by x, so that would be x cubed plus 3x squared plus 2x. Then we subtract, so x cubed minus x cubed is nothing, 3x squared minus 3x squared is nothing, so you're going to have 4x plus 7, and naturally if you look at the leading term in this into the leading term in that, you can't divide anymore, so this is your remainder. So that is your remainder. So that is telling us that x cubed plus 3x squared plus 6x plus 7 divided by x squared plus 3x plus 2 equals, so the quotient, x plus 4x plus 7 over, so quotient plus remainder over divisor over x squared plus 3x plus 2. So now we're going to proceed by looking to see what we can do with this to convert this part of the right hand side into partial fractions. So it's in a form that we're used to now. You can look at the denominator of the x squared plus 3x plus 2 plus 3x plus 2, and we can say, well, that, and it factorizes very nicely, so that is x and x. 2 times 1 is 2, and 2 plus 1 is 3, it's all positive, so plus 2 plus 1. So now we know that this denominator factorizes into x plus 2, x plus 1, we can split this part of the fraction, we can split this into partial fractions. So split the 4x plus 7 over x squared plus 3x plus 2 into partial fractions. So we can say 4x plus 7 over x plus 2 x plus 1 is identical to sum a over x plus 2 plus sum b over x plus 1. So now I'm going to add these two fractions on the right hand side. So that is going to say 4x plus 7 over x plus 2 x plus 1 is identical to ax plus 1 plus b x plus 2 over x plus 2 x plus 1. So your next step, multiply through by the denominator. I know some people do that earlier, but I think in terms of explaining it, it probably looks a lot better at this stage. So we're going to multiply both sides through by x plus 2 x plus 1, which is going to leave us with 4x plus 7 is identical to ax plus 1 plus b x plus 2. So remember, this identity symbol means it works for every value of x, so we can substitute useful values of x, which are going to be whatever takes out the term. So minus 1 is going to be really useful for getting rid of a, and minus 2 is going to be really useful for getting rid of b, so we can find a. So if x equals minus 1, 4 times minus 1 plus 7, that's the left hand side, equals a times minus 1 plus 1 is 0, plus b times minus 1 plus 2. So that is minus 4 plus 7 is 3, equals 0 plus b. So 3 equals b. Okay, we can also now try minus 2. If x equals minus 2, so 4 times minus 2 plus 7, it's not a very good 7, 4 times minus 2 plus 7 equals, so a times minus 2 plus 1 plus b times minus 2 plus 2, which is 0. So minus 8 plus 7 is minus 1 equals minus 2 plus 1 is minus 1a. So if minus 1 equals minus 1a, well, a must equal 1. So if 4x plus 7 over x squared plus 3x plus 2 is identical to a over x plus 2 plus b over x plus 1, with a equals 1 and b equals 3, so it must be identical to 1 over x plus 2 plus 3 over x plus 1. Which means finally that, remember, the initial equation was x cubed plus 3x squared plus 6x plus 7 over x squared plus 3x plus 2. Remember that when we did the division, that was x plus 4x plus 7 over x squared plus 3x plus 2. So this is identical to the x plus 1 over x plus 2 plus 3 over x plus 1.